Well, that was probably an awkward pause while I tried to get the screen up. So, yes, this is what my face looks like without a beard, but as you can tell, after shaving it all once, I haven't shaved since. So, I'm going to work through a problem in Hibbeler. This is chapter 16, problem 13. I'm using my son's Osmo, which has this fun little reflector that allows me to talk and write at the same time. So, this is problem 1316. We have some pulleys connected by belts. We'll assume that they move without slipping, so that relations we use here are no different than if they were gears connected by teeth. The condition that we're going to apply here is that the tangential velocity and acceleration must always match where the gears meet. Here, where the belt is going to meet the pulley. Starting with our own value of the angular velocity of pulley A, we have omega A is equal to 60 radians per second. We will travel along the belt and pulley system using the tangential velocity relation as needed. Well, we can fancy up our tangential velocity expression by writing it as the cross product between an angular velocity vector and a radial vector. For problems like this in the plane, it reduces to what we saw before back in physics 1, which is just that our tangential velocity is equal to omega times r. Thus, looking at the belt between A and D, we have omega A RA is equal to omega D RD. We're trying to solve for omega D, so we're going to divide by RD, cancel that out. That gives us omega D is equal to RA over RD multiplied by omega A. Note, only the ratio of these gear radii are necessary, so we don't need to bother converting. Then we can plug in our numbers. RA is this 75, RD is this 25, and then of course omega A is 60 radians per second, so that gives us 180 radians per second. For our next set of gears, we're told that the gear D is rigidly connected to B. This means that, going on to the next portion, that omega B is equal to omega D, and we just solve for that, so that's both 180 radians per second. Then B connects to C via this pulley, so we will apply the angular velocity, the tangential velocity relationship again. So we'll have omega B RB is equal to omega C RC. Then, again, we're going to divide by R sub C because we're trying to solve for omega C. So we get that omega C is equal to the ratio RB over RC multiplied by omega B. Then plugging in our radii, RB is 100 millimeters, RC is 50 millimeters. We already know that RB was 180 radians per second, and this is going to give us 360 radians per second. End of problem.